Hello everyone, I am Joshua James C. Gallardo from Group 4 and today I will be discussing about polynomials. Now, what is polynomials? By definition, a polynomial is an algebraic expression that consists of variables, coefficients, and exponents. However, it must follow specific rules such as exponents must be non-negative integers, so it has to be positive like 0, 1, 2, 3, so on and so forth. What they mean by non-negative is that it cannot be -2, -1, -4, and so on, so on, so on, so on. Now, the other rule is that no variables in the denominator. For example, 1 over x is not a polynomial. So any given polynomial cannot be like this. For example, 2 over x or 4 over x or 7 over x. It cannot be a polynomial because the x is at the denominator. It cannot be at the denominator. Now, there's also the standard form term. Terms are written from the highest exponent to the lowest. Now, there are classifications or ways to classify polynomials, such as degree or terms. For degrees, it is the highest exponent in the expression. For example, linear is 3x plus 4. The highest exponent here is 3x, as there's always a hidden 1 above. Example, 3x, as there's always a higher or a hidden exponent within it. So if you're going to say 4 and 2x, naturally the highest exponent belongs here as exponent of hidden 1. So for quadratic, it is 2, as highest exponent here is 2. And for the cubic, it is 3, as it has the third degree, cubic. Now, for the terms, it is represented by the number of terms present in a given example. For example, the monomial is one term, as there's only 7x squared. For the binomial, there are two terms, which is x and 10. For the trinomial, it has three terms, which is x squared, 4x, as well as 4. There are different strategies that you can use in order to understand polynomials better, or you can use to solve them. First is arranging them to standard form. Standard form is a fundamental strategy that is used commonly. For example, 3 plus 2x plus 2x, I mean 2x squared plus 2x. Remember what I said, that written from the highest exponent to the lowest, standard form is standard form. Now for this example, our highest exponent belongs here, which is 2. So to write this up in standard form, we have to first put the highest exponent, 2, here, plus copy this, 2x, as it has a hidden 1 exponent, and then 3, which is the constant, as it has no variable. Next is identifying the leading coefficient. This is the number attached to the highest power, and it dictates where the graph goes as x gets huge. Now, in our previous example, 2x plus x plus 3, the leading coefficient is the number coefficient, which is attached to the highest number, which is this. So our leading coefficient is 2x squared, and then the rest follows. The highest, to know this, you have to know which variable, or it has to have a variable, so that to know if it's the leading coefficient. Next is the grouping method, splitting a 4-term polynomial into 2 pairs to find a common binomial factor. For example, we have x cubed plus 2x squared minus, or rather plus 4x 2 plus 8. It said here, splitting a 4-term polynomial into 2 pairs to find a common binomial factor. So you split them, this, 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 and this. Now, your next step is going to find the common factor between these two, and that is x squared. Now, once you find the common factor, you divide it with these two right here. So x squared divided by x cubed will leave you with x plus 2x divided by 2x squared divided by x squared, which will leave you with 2. Copy this, and then the same thing goes for these two right here. Common factorial for them is 4, so we divide it. 4 divided by 4x, which is x, plus 4 divided by 8 is 2. Notice that we have the two same pairs. That pair becomes 1, which is x plus 2. Then notice these two over here. That becomes another pair, which is x squared plus 4. To really know if you solved it, you can use the FOIL method, which is to multiply them. example, x times x squared is x cubed plus x times 4x is, which will leave you with 4x plus 2 times 2x, which is 2x squared, and 2 times 4, which is 8. If you forgot about FOIL method, it is first in, then out, in, and out. Now you arrange this into the standard form, which I talked about earlier. You get x cubed plus 2x squared plus 4x plus 8, which is exactly the same as this. That's how it goes for grouping method. Now, there are different operations that you can use, which are addition, subtraction, as well as multiplication. For addition, the golden rule here is like terms only. You can only add or subtract terms that have the exact same variable and exponent. For example here, 5x squared plus 8x plus 2 plus 2x squared plus 3x plus 10. Five x squared plus 8x plus 2, our first term. Then here, 2x squared plus 3x plus 10. Now, see what I did? They're not next to each other, but rather they are layered correspondingly and is in standard form, highest term to the lowest. Now, it's the golden rule said like terms only, and that means they have to have the same variable as well as the same exponent. So 5x squared plus 2x squared is 7x squared. Then copy 8x plus 3x, you get 11x. For 2 plus 10, you get 12. That is an example of addition. Now, for the next example, we have 4y cubed plus 2y minus 5 plus 3y squared plus 6y plus 1. 4y cubed plus 2y 5, then 3 6y. Notice how the exponents are completely different from this. We got cube and raised to the power of 2. Now, to solve this, or to add this, you don't have to add these two together. Rather, you put them separately. For example, 4y cubed plus 3y squared. Since the following terms have the same exponent as well as variable, you can add them together, which is 2 plus 6 is 8y. Here we got negative 5 plus 1, which will turn into negative 4. That's how you solve for like terms. Next is subtraction. To subtract polynomials, you simply distribute the negative sign to every term in the second polynomial, changing their signs, and then combine the remaining like terms. Same with addition, where you combine the like terms. Here, you also have to combine the like terms. For example, here we got 8a plus 12 as our first term. Now, our second term is 3a plus 5. Notice how it says that you have simply distribute the negative sign to every term in the second polynomial. Our first term is this, and our second term is this. It says changing their signs to distribute them. Since we have a positive 3a, it will turn into negative 3a. And we also have a positive 5, it will turn into a negative 5. Now, it says that you then combine the remaining like terms. So you combine the like terms by grouping them up like this. 8a minus 3a. Then we have 12, positive 12 minus 5. After that, we solve for this. 8a minus 3a becomes 5a. And then 12 minus 5 becomes 7. That is our final answer in subtracting polynomials. First step is to change the signs, which you did here, here, and then combine the like terms. You add them here, then you add this here, and then you solve it. That's how you get this answer. Another example is this: 5x squared minus 2x x squared squared minus 8x plus 3. Remember that first you have to bring this down, just 5x squared minus 2x, and then see that this is a positive x squared. We turn it into a negative x squared. This is a negative 8x. Now turn it into a positive 8x. You are basically changing their signs to the opposite. So if it's a negative, it's a positive, it's a positive. If it's a positive, you turn it into a negative. See that this is a positive 3. Now it becomes a negative 3. Then you group it up together, which is, you group it up like 5x squared minus, notice how there's no number here. There's nothing here. Always assume that if there's a variable with no coefficient, it's always 1. So it's 1x squared. And then the next is 2x, 2x plus 8x. The constant can remain outside. Now, since you've arranged them by pair or by groups, now you solve them. 5x squared minus 1x squared is 4x squared. 4x squared. Negative 2x is positive 8x will become 6x. Then keep 3. And that's how you solve this. Next is multiplication. To multiply polynomials, you distribute every term of the first polynomial to every term of the second polynomial, adding exponents for the variables and then combining any like terms to simplify the final expression. There are three different ways on how to multiply polynomials. By example, binomial distribution, to FOIL distribution or FOIL method, and difference of squares. So for the monomial distribution, let us give you an example, which is 3x, 2x squared minus 4x plus 5. Now, for this, you have to distribute this term to every single one and multiply them. So, for example, 3x times 2x, which is 3x cubed. Notice how it said to add the exponents, 1 here and then 2, so it's a third, 3x cubed. Now you get 3x times 4x to negative 4x, which is negative 12x. Squared, because there's always 1 right here. Now you get to the third one, 3x times 5. Now, because it's a constant, you simply multiply them. 3x times 5, which is 15x, because there's an x here. And this is your answer. 3x cubed minus 12x squared plus 15x. Now, this is an example for distribution. Let's go for FOIL method. For our FOIL method, we use the problem x 4 x plus 9 remember the FOIL method, which is first in, then second out, first in, second out. First multiply x with x, which is x squared, then multiply x with 9, which is 9x. Now you multiply 4 by x, which leaves you with negative 4x, and then you multiply negative 4 times 9, which is 39. This is your final answer. Oh, I got that wrong. It's supposed to be 36. 36. Negative 36. This is your answer. Now, let's move into the final way to multiply. The next is the difference of squares. Now our problem here is 2w is 5 for our first term, then for our second term, which is 2w plus 5. Now, it's essentially the same with FOIL method, which you distribute this to the in to the out, in, then out. 2w times 2w, which is 4w squared. 2w times 5, which is positive 10w. Here, negative 5 times 2w is negative 10w. 5 times 5 is positive 25. 5 times 5 is 25. Now, you can solve this by simply bringing down 4w squared and then 10w minus 10w, which cancels out each other, so it becomes 0. Now, because of that gap, add this plus, rather minus 25. So our final answer is 4w squared minus 25. That's all for the operations.
Good day everyone, good day sir. I am Engine Cadet Redondo. I discuss to you about factoring polynomials. Factoring is the opposite. Multiplication is taking a finished product and writing it down its original components factors. The GCF greatest common factors method. This is always your first step. You look for the largest number and the highest power of variable that fits into every term. So we have a problem here. So step 1, find the largest number that divides into 6. So 6 so mag-una ta sa 12 no. Pangitaon na to iyang greatest common factor sa 12. 1 2 3 4 6. So wala sa 12. So sa 18 na punta 1 2 3 6 9. So wala sa 18. So sa 6 ta 6 1 2 3 6. So naa sa 6 ang largest number na to kay 6. So ibutang na to 6. Ibutang na to 6. So next, step 2, find the highest power of x shared by all terms. So ang highest power man nato kay x, so ibutan nato dire x. Next, step 3, divide each term by 6x and place the leftovers in parentheses. So no, i-divide na to siya diri sa kwan. I-divide na to ni siya diri ang kani i-divide na to diri anya ang kani i-divide na to diri. I-divide na to siya each term. So 6x cubed divide 12x squared. So ang answer niya kay x2. So close parentheses x2. Next, bring down ang plus. And next 6x divide negative 18x. So ang answer niya kay 2x negative 3. So close parentheses. So ang answer niya mao ni. So ang answer niya mao na. Next, factoring trinomial. So next, factoring trinomial. This is used when you have three terms. You are looking for two numbers that play a double rule. So we have a problem. Here. Step 1, find two numbers that multiply to give 10, add to give 7. So natay less factors of 10. 1 and 10 and 2 and 5. So step 2, check which per works. Karon ni check na to siya. Per adds up to 7. 1 plus 10 equals 11. So bawal siya. 2 plus 5 equals 7. So the correct number are 2 and 7. Step 3, write the factors. So kabalo naman ta sa iyang factors 2 and 5. Isulat na nato iyang factors. Close parenthesis. So x plus 2. So 2 man to ang 2 man to yung factors sa una. So next, close parenthesis, x plus 5. So mao ni ang answer. So mao ni ang answer. Ingan ra siya. Factoring. Difference of a square. This is special that only works if you have two terms. Both are perfect square and they are being subtracted. So we have a problem. Step 1, find the square root of the first term. And step 2, find the square root of the second term. Step 3, write them in two parentheses, which a plus and one which a minus. So we have a pangitaw na to yung square root ani, pangitaw na to yung square root. So 25x squared ang square root niya kay 5x 5x. So in the square root of the first term and second term. So pangitaon na to yung square root aning 25x cube and 24. So ang square root sa 25x is x squared kay 5x. So answer niya, close parenthesis, 5x plus x and then plus so 20 next. So step 2, no, write them in two parentheses with the plus and with a minus. So only that siya, no, plus and minus. Next, 25x squared, ang square root 64, ang square root sa 64 kay 8. So ibutang na to dire 8 close parenthesis. So close parenthesis sa and then sa 25 x squared, so ang square root niya gihapon na kay 5. So x na to dire and 1 with a plus and 1 it's a minus man, so minus ni siya dire, minus madali na ako ibutang sa ubos, minus kuman 24 square root sa 24 kay 8, so 8 ni siya dire. So ang answer mo ni siya mo na yung answer. 5x plus 8 close parenthesis 5x may negative 8. So mao na yung answer. Solving polynomial equation. Simplify and solve for x when the equation is close parenthesis 3x squared plus 5x negative 8 plus 2x 2x squared negative 2x plus 3 equals 0. Solve for the x if the area of rectangular bulkhead is x plus 4 close parenthesis x negative 2 close parenthesis equals 7. Solve x cube negative 3x squared plus 4x negative 12 equals 0. So mauna siya sa solving polynomial equation. So next, relations in mathematics relative is any set order pairs x and y is a described on input independent variable matches with the output independent variables domain the set of possible input values, the range of the possible temperatures for an engine, range, the set of all possible output values, the resulting oil pressure. So na while every function is a relation, not every relation is a function. The function rule A relation is a function of every input x there is exactly one output. So mo na yung mga example sa function na siya set A and set in B. Mo na example sa function en1 bn2 cn3 dn4. So sa not function na siya set A na po siya set B. So same lang gihapon sa function. Ang iyahang kwan en1 bn2 bn3 dn4. So mao ni sa ang example sa relations. So
Good day everyone, my name is Edwin Masiga. So today, I will discuss the graphing and end of behavior of polynomial function. So understanding the graph is very important, especially in engineering, mathematics, and even maritime application. Graphs help us to understand how values change, predict behavior, and analyze the real-world situation. In this presentation, we will talk about the part of graph, the degree of polynomial function, end of behavior, the leading coefficient test, and example and application. So, let's begin. So, in this picture, we will explain the basic part of a graph. So, first is the y-intercept. The y-intercept is the point where the graph is crossed the y-axis. It happens when x equals 0. This represents the starting value of the situation. So, for example, in the fuel consumption, the y-intercept shows how much the fuel we have at the time 0. Next are the x-intercept, also called roots or zeros. These are the points where the graph crosses the x. At this point, y is equal to 0. This tells us when something becomes 0, like when a tank becomes empty. These slides also explain the degree of a polynomial. If the degree is 1, the graph is linear, which is a straight line. If the degree is 2, the graph is quadratic, which is a U-shape. If the degree is 3, the graph is cubic, which is formed as a S shape. The degree helps us to understand the overall shape of the graph. So here's the degree of polynomial example: first degree, second degree, and the third degree. As you can see, the linear, which is a straight line, and the quadratic, which is form a U shape, and the last one is the cubic, which form is a S shape. So the degree helps us to understand the overall shape of the graph. Understanding the polynomial graphs. Polynomial are mathematical expression that involves variable rise to the whole number powers. The degree of polynomials is the highest power of the variable. It determines the shape of the graph. In a degree 1, a polynomial is called a linear function. Its graph is a straight line. For example, y is equal to 2x plus 1 raised upward and crosses the y-axis at 1. Linear graph is a constant slope and do not curve. So, straight lang siya, guys. And for the second degree, polynomial is called a quadratic. Quadratic function is a graph form a U shape, also called a parabola. For example, y is equal to 2x, curve upward. The curve can open upward or downward depending on the coefficient of 2x. The highest or the lowest point of the curve is called vertex. For the last degree, polynomial is called a cubic function. It's a graph form an S shape, rising and falling across the axis. For example, y is equal to x third, pass through the origin and changes direct in the middle. Cubic graphs are the more complex because the highest power is 3, creating curved turning point. So now, let's proceed to how to find the end behavior. The end behavior shows what is those when x goes to positive or negative infinity. So at these slides, I will explain the end behavior. End behavior shows what happened to the graph when x become very large positive or very large negative. We use something called the leading coefficient test. We took at two things. First, the degree. The second, the design of leading coefficient. In this example, we use the third degree, which is the odd. If the coefficient is positive, the left side goes down and the right side goes up. If the coefficient is negative, the left side goes up and the right side goes down. So for odd degree function, the graph moves in opposite direction on each side. So here's the example. So here's the end behavior of cubic function. Degree 3. Positive leading coefficient and the negative leading coefficient. So just like I said, the positive leading coefficient, left side goes down and the right side goes up. So the negative leading coefficient is the left side goes up and the right side goes down. So just like opposite direction. Opposite direction siya sa positive o negative. So baliktad lang. So here's the another example of end behavior of polynomials, the leading coefficient test. So here's the positive and negative. So end of behavior of polynomial function describe what happened to the graph as x become very large or positive, very small or negative. To determine this, we use the leading coefficient test, which looks at two things. First, degree of polynomial, and the second is the sign of leading coefficient. For cubic function, which are the polynomials of degree 3, the graph has S-shaped curve and behave differently on each side because the degree is odd. If the leading coefficient is positive, the left side of the graph goes down and the right side goes up. On the other hand, if the leading coefficient is negative, the left side goes up and the right side goes down. So in short, the degree of determine the general shape of the graph, while the leading coefficient controls the direction of its end. For cubic function, this means the graph moves in opposite direction on each side, creating the characteristic of S shape. Understanding the end behavior helps us predict the overall trends of the function and useful when sketch or analyzing polynomial graphs. So now, in this slide shows even degree function. Example of even degrees are 2, 4, and 6. For even function, both ends move in the same direction. If the coefficient is positive, the both ends go up. If the coefficient is negative, the both ends go down. That's why quadratic graphs like y is equal to x squared looks like a U shape, and y is equal to negative x squared looks like an upside down U. So remember, odds degree, opposite direction, even degree in the same direction. For showing an example problem, I'll show you a video of how to solve a graphing or how to find a graph.
So for the next example, same idea. We want to find the value of the leading coefficient here. Well, we have here x cubed, x, which will be to the power of 2, and then an x, which will be to the power of 4. So putting this all together, the leading coefficient will be x to the power of 3 plus 2 plus 4, which gives us a leading coefficient of x to the power 9. Labeling our roots here, we have a root at 0, a root at -1, and a root at 5. And now once again here, we can see here that as x gets infinitely large, our end behavior becomes positive infinity. So we're starting up here. We're going to tend towards the root of 5, and because it's even power, we're going to bounce off that root, tend towards the root of 0 because the power is odd. You can see here it's to the power of 3, it's going to cross, tend back towards the root of -1, and because the power is even, it's then going to bounce. And we have our sketch. Let's try another. For the next example here, same idea. This leading coefficient will be x to the power of 4, x, and x. So here we have a leading coefficient equal x to the power of 6. Again, this is positive. Identifying our roots here, we have a root at -1, a root at 1, and a root at 2. So as x gets infinitely large, we can see our end behavior will tend towards positive infinity. Notice here that we have a power that's odd, a power that's odd. So we're going to be, as we approach, let's label this for ourselves here. And you can see here I've labeled what's going on here. As I approach 2, we're going to cross. As I approach 1, we're going to cross. And then at -1, we're going to bounce. So we're starting up here at positive infinity. So we're going to tend towards our root. We're going to cross, tend towards our root, cross, tend towards our root, and bounce. And we have a rough sketch of our polynomial here. Let's take a look at another example. In our next example here, we want to find the leading coefficient. Again, the leading coefficient is going to be positive, and it's going to be x to the power of 2 plus 4 plus 10. So we're getting x to the power of 16. So again, draw your number line and find your roots. We have a root at -3, a root at -1, and a root at 2. As x gets infinitely large, we're starting up here at positive infinity. Now again, let's label what's going to happen as we approach our roots. So you'll notice here the powers are all even on this polynomial. So what's going to happen is as we approach our roots, we're going to bounce on each of these. So again, our end behavior is positive infinity. So we're going to tend towards our root of 2, and we're going to bounce. Go back up, tend towards our root of -1, bounce. And once again, go back up, tend towards our root of -3, and bounce again. So this is a rough sketch of our polynomial here. Again, the even powers mean that we'll bounce at each one of these roots. Let's take a look at another example. For the next example here, let's find the leading coefficient. The leading coefficient here is going to be, it'll be x cubed, plus we have a power of 1, plus a power of 1 happening here, here, and here. And then again, because that minus sign in front, that's going to make this negative here. So our leading coefficient will be negative x to the power of 5. So again, draw your number line. We have a root at 0, another root at 5, watch out there, and another root at -1. So again, this is a root at 5. So you set what's in the brackets equal to 0. Now again, as we discover this here, as I let x get infinitely large, you can see here that the end behavior approaches negative infinity. And therefore, end behavior is down here. Let's label what's going to happen as we cross our roots. And again, I'm starting here at negative infinity. As I tend towards my root, we're going to cross, we're going to cross, we're going to cross. So you can see here that in this situation here, because all the powers on the roots were odd, we're crossing every time we approach that root. And we identified our end behavior as being negative infinity. So that gave us kind of our starting point. And then we can go ahead and graph our degree 5 polynomial. Let's look at another example. So in this example here, same idea. We want to find that leading coefficient. So let's go ahead and find the leading coefficient here. This will be x to the power of 2, power of 3, to the power of 4, to the power of 5, and then to the power of 6. And the leading coefficient will be negative x to the power of 6 here. So again, draw your number line and find your roots. We have a root at 0, another at 1, another at -2, another at -4, and then another root at 3. And let's label what's going to happen as we approach these roots. And you can see here the powers in all these roots are odd with the exception of our root at 0. So we're crossing everywhere except for at 0. We're going to bounce. As x gets infinitely large here, again, as x tends towards positive infinity, we can see our end behavior is negative infinity. So we're going to go ahead and tend towards our root of 3 and cross, tend towards 1 and cross, tend towards 0 and bounce, cross, and cross. So this would be a rough sketch of our polynomial of degree 6 here. That concludes today's lesson on sketching higher order polynomials. Thank you.